So here's an example of solving a system of equations, and what we want to do is we want to reduce this, so we want to kind of pick a variable that we're going to eliminate, and it really doesn't matter which one. You can kind of look at it, and if you find one it looks like it's going to be easier to get rid of, then you can do that. Otherwise, you just pick one at random. So when I look at these three equations, x, y, and z, for equation 1, 2, and 3, I got three variables. It seems like, well, if I multiply this by 3, I can get the x's to cancel. And if I multiply this by 2, I can get the x's to cancel here in equation 1 and 3, or 1 and 2. So I'm going to use a pair of equations to eliminate the x twice. And then I'll end up with two equations with two unknowns. So let's just do that. So what I'm going to do is I'm going to try to eliminate x. So what I'll do is I'll just write over here that x is what I'm going to try to eliminate. I'll just put a circle around it. So I'm going to try to get rid of the x. You might want to eliminate the y or the z. You can do that. But I'm going to pick x. And I'm going to take equation number 1. And I know if I take equation 1 and I multiply it by 3, I'll have opposites with equation 2. So I'll take equation 1 and I'll multiply it by 3. And when I do that, I've got 3x plus 9y plus 6z equals negative 3. And remember, label your equations because there's going to be a lot going on here. So this is equation 1. I'll double check it. 3x, 9, 6, negative 3. And then I'll take equation 2 and I'll just write it the way it is. Negative 3x, negative 2y, plus z equals 3. Okay? And now if I take these two equations, if I add these two equations, should have used a ruler. Okay? So if I add these equations, try that again with a ruler. There we go, it's better. When I add these equations, the x's, you see, become 0, so I end up with 9 minus 2 is 7, so 7y plus 6 plus 1 is 7z equals 0. All right. And that's going to be a new equation, so I'm going to call that equation 4. Now I'm going to take equation 1 and I'm going to group it with equation 3, and I know that if I take equation 1 and multiply it by negative 2, I'll have opposites with equation 3 to get rid of the x, that is. So I take equation number 1, and I'm going to multiply it by negative 2. So equation 1 will now be negative 2x, negative 6y, negative 4z equals positive 2. I'm multiplying each term by negative 2. And then I can write that right next to, and I can put equation 3 here. Oops, just as is, that's a little close here. And equation 3 is this one. I can put it close. 2x minus y plus 3z equals negative 8. Okay? And then we'll just add those two equations up here. And again, the x's become 0, so I have now, and I'll call this equation 5, this is a new equation, negative 7y, and then negative 4 plus 3 is negative z, equals negative 6. All right? So these are my two new equations. And now notice I've only got two unknowns. So now I can do as we did before, solve these two equations. So I'll rewrite these. That'll be equation number 4. And this is 7y plus 7z equals 0, and equation 5 minus 7y minus z equals negative 6. Now, I could work these so I could add them and I can get rid of one of the variables. In other words, if I multiplied equation 5 by a 7, these would be opposites. I might have to multiply both of these, but these are two equations with two unknowns, and we already know how to do that. We did these before, some earlier worksheets. So, but this happens to work out really nicely because if I add these, look what happens to the y's. They just cancel, so I don't even really have to do anything. But you know how to do that because we did these. So the main idea is to take two equations at a time and eliminate one of the variables, and then take a different two equations and eliminate one of the variables. So we used equation 1 and 2, then we used equation 1 and 3, and we came up with two equations, and then once you have two equations with two unknowns, you know how to solve those because we already did that. But in this case, it works out real easy because when I add these, this y's just zero out, so I have 7 minus 1, so I have 6z equals negative 6. If I divide both sides by 6, I get z equals negative 1. So once you solve your two equations with two unknowns, okay, then you go back and then you can, well, you have to figure out what the other unknown is, so we can put negative 1 into either one of these. So I'll take equation 5, that looks like the easiest one. And equation 5 says negative 7y minus z, but what is z? Z is negative 1 equals negative 6. So that's the same thing as saying negative 7y plus 1 equals negative 6. Then if I subtract 1 from both sides, that's like saying negative 7y equals negative 7. If I divide by negative 7, y equals 1. Now I know what y is, and I know what z is, so I can go back into any equation, and I can find out what x is, so I'll go all the way back up here to equation number 1. I'll write it over here so you can see it. Equation number 1 says that x plus 3y plus 2z equals negative 1. You can see that up here. And then we'll just substitute. X is what I'm looking for, so x plus 3 times y plus 2 times z equals negative 1. And what was y? Y was 1, and z was negative 1. And then we'll find out what x is. So x equals 3, x plus 3, and this is going to be minus 2 equals negative 1, 3 and minus 2. So 3 minus 2 is 1 plus 1 equals negative 1. And then if I subtract 1 from both sides, I end up with x equals negative 2. So those are your three answers. You could write that over here. X equals negative 2, y equals 1, and z equals negative 1. So if you know how to solve two equations with two unknowns, you won't have any trouble. So what you try to do is you try to reduce these. All right? So I hope that makes sense. And I don't think I did any examples of two equations with two unknowns because we did a lot of those in class, but what I can do is I can try to do one of those, and you can see what to do with those, just to kind of review. Okay, I hope that helps.